All right, welcome. So, you're getting ready to get behind the wheel of a commercial vehicle. Well, understanding its most critical safety feature is totally non-negotiable. Today, we're going to dive into the air brake system, break down how it works, and most importantly, what you, the driver, are responsible for. I mean, just think about it for a second. We're talking about 80,000 pounds hurtling down the road. The sheer force, the momentum, it's just immense. So how in the world do you bring all of that to a controlled, safe stop, time and time again? Well, the answer might actually surprise you. Yep, that's right. All that incredible stopping power comes from plain old compressed air. It's this totally invisible force that, when you harness it the right way, becomes one of the safest and most reliable braking systems out there for heavy vehicles. So in this explainer, we're going to follow the path of that power. We'll start with why we even use air, see how it's generated, understand the 3 different brake systems it runs, trace its path all the way to the wheels, check out the built-in safety nets, and then tie it all together from right there in the driver's seat. Let's do it. Okay, first up, the power of air. So why air? Why not something else? Well, to put it simply, air brakes are a really good and safe way to stop these huge, heavy vehicles. But, and this is a huge but, they are only safe when they are well maintained and used properly. And that, my friend, is where you come in. All right, so where does all this powerful compressed air even come from? Let's take a look at the parts that actually create and control the pressure. This is really the heartbeat of the whole system. It all starts right here with the air compressor. You can think of this thing as the heart of the system. It's the engine's trusty sidekick, hooked up with either gears or a V-belt. And its one and only job is to pump air into the storage tanks, building up the pressure we need to get that truck stopped. Now, if the compressor is the heart, then the governor, well, that's the brain. It's super smart, and its job is to make sure the system doesn't get overpressurized. So when the pressure gets up to about 125 psi, that's the cutout point. The governor basically tells the compressor, hey, take 5. Then, once the pressure dips back down to around 100 psi, the cut-in point, it signals the compressor, all right, time to get back to work. It's just this constant automatic balancing act. And this is where your first real hands-on responsibility comes in. Before you even start your trip, if the compressor has its own oil supply, you need to check that level. And at the end of every single day, no exceptions, you have to drain the air tanks completely. This gets rid of any moisture and oil that could freeze or just plain damage the system. Okay, so we've got the air. Now let's see how we actually put it to use. Here's something you might not realize. An air brake setup isn't just one system. It's actually 3 distinct systems, all using that same supply of compressed air to do very different and very critical jobs. Check it out. First, you've got your service brake. That's your everyday brake, the one you use when you press the pedal. Then there's the parking brake, which you set with that knob on the dash to make sure your truck stays put. And finally, you've got the emergency brake. This is your ultimate failsafe. It uses parts from the other 2 to stop you if there's a major air loss. 3 systems, 1 goal, safety. Okay, now this next part is a concept you absolutely have to get. It's all about something called spring brakes. This is how the parking and emergency systems work. Just imagine these incredibly powerful springs that are always trying to clamp down and apply the brakes. The only thing stopping them is air pressure pushing against them, holding them back. And that brings us to the single most important safety principle in this entire system. Remember this. It's the loss of air pressure that causes the brakes to apply. It's a genius fail-safe design, right? If the system has a major failure and you lose all your air, those powerful springs are finally released and their mechanical force takes over and stops the vehicle. So we've made the air, we know about the 3 systems, but how does pushing that pedal in the cab actually make the wheels stop turning? Let's follow the air on its final journey from the pedal to the pavement. This is where the magic happens, at the foundation brakes on each wheel. Now, the most common type you'll see are S-cam brakes. When you hit the brake pedal, a blast of compressed air goes out. That air pushes on a rod. The rod turns this S-shaped cam, and that cam forces the brake shoes out against the drum, creating the friction that stops you. All right, but what happens when things go wrong? What if your air pressure starts to drop? Well, the system is designed with multiple layers of warnings. They're all there to give you, the driver, a heads up so you can act before it becomes a real crisis. This is your safety net. Okay, I want you to look at this number and just burn it into your memory. 60 psi. When we're talking about your air brake system, this is, without a doubt, the single most important number you need to know. Why is 60 so important? Because the rules are crystal clear. A warning signal, we're talking a red light you can see, maybe a buzzer you can hear, must come on before the pressure in your tanks drops below 60 psi. This isn't a suggestion, it's a requirement. It's your first, most critical alert. When that light pops on, it's not time to negotiate. It's not, oh, I'll just get to the next exit. No, your training and professional responsibility demand one thing and one thing only. You bring that vehicle to a safe stop immediately. Then you figure out what's wrong. Now, this is what happens if you ignore that warning or if there's a catastrophic air loss. If the pressure keeps plummeting, somewhere down between 45 and 20 psi, those spring brakes are going to run out of air to hold them back, and they will automatically apply. The truck is going to stop one way or another. All right, let's bring all this tech back into the driver's seat, because as the driver, you're the commander of this whole system. And your dashboard, well, that's your command center. It gives you all the information you need to operate safely. Your eyes should constantly be scanning these instruments. The supply gauges tell you how much air you've got in the tanks. The application gauge shows how hard you're actually braking. You already know all about that critical red low-pressure warning light. That yellow, diamond-shaped knob, that's your parking brake. And that other yellow lamp tells you if the anti-lock brake system has a fault. And you know, these systems have really evolved. Older trucks sometimes had manual controls for slick roads, but technology marched on, and since the late 90s, anti-lock braking systems, or ABS, have been required on new equipment. It's another layer of electronic safety built right on top of the foundation air brake system. And you know, all of this brings us back to what might be the most important point of all, a direct quote from the manual. This system is brilliantly designed, with redundancies and fail-safes, but none of it matters without a professional, knowledgeable driver. So as we wrap this up, the final question isn't about PSI or SCAMs. It's about you. Understanding the mechanics is the first step. The next is embracing the immense responsibility that comes with operating the system safely on our public roads every single day.